my next video. It's going to be on declination and what exactly declination means and how to use it on your map. Got this little prop here. I know my stuff isn't too highly technical or anything like that. My daughter's felt all my years of experience that I should give some classes on some stuff. So that's what I'm doing. This is a little beach ball I took from one of my girls, and I'm going to explain to you what declination is. Declination is basically an angle, and it's magnetic north and true north. It's the difference. So what I've done is drawn a line here, the agonal line, which is located down the center of the United States. And I'll show you on this map also when we get to it. But basically, about 1,000 miles south of the North Pole is where the magnetic pole is drawn to from your needles on your compass. It's not directly in line with the North Pole, except when you're directly below this agonal line right here. Agonic line, I'm sorry. And if you're anywhere west or east or west of the agonic line, your compass needle is going to be drawn to that side. So for example, if you're on the East Coast, say you're in Maine or New Hampshire, your needle is going to be drawn to the west side, to the west coast, because the magnetic pole is up here. That's because the Earth rotates at an angle like this, and anyway, we won't get all technical on it. I'm not a scientist, but basically if you're on the west coast, your needle is going to be drawn to the east. If you're on the east coast, your needle is going to be drawn to the west. Well, that's called declination. That's what it basically is, it's an angle. And so to make it simple, to explain it to you, what I've learned in the Army years ago as an infantry private and coming up through the ranks, I've learned how to basically put this in simple terms, and the way the Army taught me is just an easy way to remember it. So I'm going to put this aside. I'm going to show you the map here. Basically what I've done here is I've drawn on this map, this is your agonic line, and that's 0 degrees. So if you placed your compass on that, theoretically you would be directly below it, and you would be perfectly aligned with the North Pole and the magnetic pole, which would be right here. Anywhere else in the United States, whether you be over here in the west or in the east, it would actually draw your needle to that magnetic point. So to make things a little bit simpler, I've drawn the actual degrees 2010 on this map, which is the most accurate one I have. And I'm going to show you an Idaho map because I don't have a Texas map. But basically, the Mississippi is considered the dividing line. They used to teach us in the military, the Mississippi is a good way of knowing the dividing line. For example, you look here, I've highlighted the Mississippi, and for the most part, within 50 miles or so, it's on that agonic line. And so if you want a quick remembrance of where that line runs, the agonic line, just think of the Mississippi River and the west side, the east side of the United States. So this line here changes, okay? This magnetic base in the center, it changes every 3 or 4 years. So when you get a map, you want to make sure that your declination diagram is accurate within the last 5 years, because this shifts, and it's a slowly shifting towards Siberia over here. So the whole line is shifting to the west coast, basically. So what you do is when you get your map for wherever you're going to go, here I've got an Idaho map. And if you zoom in on this here, you'll see that it shows magnetic north, grid north, and the star is true north. You're looking for magnetic north. That is what this line is drawing you to, and it'll tell you the degrees. So you've got 14 degrees. And that's basically right here in Idaho. So this Idaho map, I'm going to show you how we do it. And at 14 degrees, you're saying, okay, so what do I do with that 14 degrees? So I've got several compasses out here, and I'm going to show you, if you're wherever you're at on the United States, you can actually figure out how to do it real simple. The old thing they taught us in the military was west is best, east is least. What they mean by that is west best meaning you add, and east least meaning you subtract. So you're saying, okay, well, what does that mean? Well, basically in the military you always start with your compass, all right? So taking your compass bearing and going to your map. So you're taking a magnetic azimuth and going to a grid azimuth. Grid azimuth is what the map is going to have, and your compass is the magnetic azimuth that's going to be drawn to the North Pole, or the magnetic north. So basically, what you're going to do is take your map, get your declination diagram here, and I'm doing this upside down, so bear with me. And I'm going to show you with 2 different types of compasses how you can do it, because we're not in Idaho right now. So you find your declination, you know it's 14 degrees. You'll find these latitude and latitude lines, which are on your grid, on your UTM map. You line up this up, and you'll turn these to north. You notice in the center of the compass, they're meridian lines or orientation lines. You'll line those up with these lines here, get them lined up, and then what you'll do is look at your 14 degrees, and you're going to notice that you're going to turn that so you have 14 degrees on there. Now your map, you just turn your map so that it's at 14 degrees and that these are lined up. When you see 14 degrees on there and these lines are lined up, you've orientated your map towards that side. Now we're doing this in the West Coast, okay? So we're gonna say we're in Idaho. Right now we're in Texas, which is only, you can see by the map, we're about 6 to 8 degrees of variance. So we're just basically giving you a demonstration here. So what you do is after you orientate your map, and you want to know, okay, so how does that work that west is best, east is least? Well, the way that works is you take and you lay your map down and you've done your grid. And let's say you look at your map and you want to come up here up this road in Idaho. And you get to this point and you think, I think I'm here because there's a creek. So you take and your compass and you shoot an azimuth. You go, okay, look, I see a creek and I see a mountain over here. Now, this is just hypothetical because we're not there. So you take your compass and you shoot an azimuth to that and you go, okay, it's 100 degrees. So you got your magnetic azimuth now, and here's where that add and subtract comes in. So you've got your magnetic azimuth, you want to convert it to your grid azimuth, which is on your map. So what you do is, like I said, west is best, you're in the West Coast, so you're going to add that 14 degrees. So if you shot an azimuth of 100 degrees, you're going to add 14 to it, and it's going to be 114 degrees on your map. If you were to take the 100 degrees from your compass and go on the map and try to find that mountaintop at 100 degrees, you're going to be off. You're going to be off to the left of that object that you're looking at. On the East Coast, you'd be to the right of the object. But basically, you're going to add that 14 degrees. I hope I'm not making this clear as mud to you. But you're going to add the 14 degrees. Best is west. You add the 14 degrees. If you're on the East Coast and you're doing the same thing, you're shooting 100 degree azimuth. Because east is least, you're subtracting. You're going to subtract that 14 degrees. So you shoot that 100 degree azimuth and you go, okay, I got 100 degree azimuth, but you look on your map and go, well, I'm not there again. So again, because you subtract, east is least, you subtract the 14 degrees and you're down to 86 degrees. And that's what you look for on your map, you find it. And I'm not going to get into triangulation or biangulation or intersection or resection. I will teach those classes later when I actually go out to Idaho, and I'm going to have my wife there and I'm going to show her some of the land navigation and stuff that you can do and how to orient yourself with the map, and I'll do a much better job. This was basically just, I figured I'd do this at home to give you an idea about declination and how it affects you. It's just a easy thing to remember. West is best, east is least. Keep that in mind when you do it. West is best, you subtract, or you add. East is least, you subtract. The other thing you think about, if you don't want to go through all that hassle, I bought my wife one of these compasses, and it's an ARC 20, and you can get them on a lot of cheap compasses now too, and you can actually adjust the declination into the compass itself by turning the inner base on the inside. You push down on it and turn it, and it will change your declination so that every time you place it on the map and you're shooting azimuth or bearing or heading, whatever you want to call it. The Army calls them azimuths, civilians call them bearing or headings. Either way, it's the same thing. You can adjust it. The problem I have with that is if you're a person that hunts all over the place, you're going to have to remember to change that, because if you don't, you get somewhere you're going to be off, and you could be, at 2 clicks or 3 clicks, which is 1,000 meters each. You could be a half a mile or a mile off, depending on how many variances you make and you're shooting your azimuth points to your different trees or whatever objects you're using. So I don't like using that. A lot of people do. I don't like it. I'm an old compass guy. I like using the aesthetic compass, which is, some people find that complicated. I like the military compass. I think it works great. I also have this as a backup, a standard one, and it works great also for shooting. Now, I will show you how to shoot azimuths and everything else at a later date. Now, I'm trying to get this done in a short period of time and just give you the basics. But if you can see again on the map, here's your agonic line. It runs down the Mississippi. Anything west of Mississippi and east of Mississippi, you can consider those are going to go up. So the further you go out from the agonic line, you can see on both sides I'm going out 3 degrees, 6 degrees, 9, 10, 12, 14. You get all the way out here by New Hampshire or Maine, you're getting 15, 14 degrees. You get out here all the way to Idaho and Washington, you're getting 18, 16 degrees depending on where you're at. And basically what that means is your needle is drawn east. Why I have east on these is as your compass draws that direction, it's drawing to the east. If it's over here, it's drawing to the west. And I don't want to confuse you by saying, oh, it's an easterly declination or it's a westerly declination. The quickest way to remember it is if you're in the West Coast, Remember, west is best. Just add those declination to it. If you're in the east, east is least, subtract it from it. And make sure you get a map that's updated, because like I say, every 5 years or so, this will change. Make sure you get the date on the map that tells you when it is, and make sure that it's accurate, because what happens is, this one's 2014. This does shift, and it eventually is shifting. When it first came out, the agonic line was here closer to Florida. And now it's, you know, here going through Mississippi, Baton Rouge, and Lake Pontchartrain. So eventually it's going to end up, you know, closer to Texas, because it is moving slowly. It does change every so often, every several years. So keep that in mind, and I hope that helped you. I hope I didn't explain that too fast or go. I have a tendency to have a lot rattling around my brain at 58 years of doing stuff, and just trying to give a quick class on it. And when I get up there, I'll do a more expert demonstration on it. The other thing I like to show before we go, I didn't want to do a whole Venus. I showed my daughter earlier how to do a shadow stick, and we're going to walk over here. I'm going to show you a shadow stick, how you can basically get direction with it, and how you can do it rather quickly. You take a 4-foot stick, at least 4-foot stick, and the reason why I use a 4-foot stick is you get a more accurate measurement. As you can see here, this was our first measurement, and you can put a stick or a stone or whatever. This is the first one we got earlier today. And then 12 minutes later, this was where our second stick measurement was. So now, with a shadow stick, wherever your first shadow cast in the northern hemisphere is going to be towards the west. So this was going to be a westernly. The second one, 12 minutes later, tells you that's easterly. So you can just draw a line or lay a stick like I did, and you know that this way is west and this way is east. You can also tell a little bit of time by it. I put this stick further in because we're getting close to noon. It was shorter, and eventually it'll move its way back out as it goes easterly, as this, you know, because the sun rotates east to west. Everybody knows that. So the shadow is cast in the northern hemisphere in that direction. So you know now that you have a westerly here, an easterly here, and you know south is this direction. Another thing you can do to get direction is with your wristwatch. You can take the hour hand, which is a small one. I had to explain that to my daughters because they're all into digital technology now. Take the small hand, point it up to the sun. Don't look at the sun. Point it up to the sun, and then wherever the 12 o'clock is on your watch, we're at 1 o'clock right now, so it doesn't leave much variance. You basically do an imaginary line between there, hold it up to the sun, look at the sun, we're right there. So south is that direction basically. And that's basically coordinates with what we've got here with our west and east line. So it kind of gives you a direction during the day that you can do, and you can do it within 12 minutes with a shadow by using at least a 4-foot stick. And you can see it doesn't have to be straight. The straighter it is, the more accurate it'll be, the quicker it'll be. But there's a lot rattling around in this brain about survival stuff. So anyway, when I get up to Idaho, if it's a clear night or the stars are out, and I can show you some of the ways to navigate by stars. I can show you how during the autumn months you can use Orion the Hunter, Mintaka, to do east to west also. By following it travels east to west sky during the autumn months. Also, I can show you how to find the North Pole, Polaris, by using Cassiopeia and the Big Dipper, because they rotate counterclockwise around the North Star, Polaris, and it helps you get direction that way at night using the stars. Well, that's my video. German Shepherd's going crazy in the house. I tried to rush through this. I hope you learned something from it. If not, put it at the bottom and I'll redo it if I have to, or re-explain some stuff for you. And I hope that helps you. Thank you.